Hello. Everybody hear me? Hello. Welcome everyone to tonight's Scottish Blockchain Meetup. Thanks for all coming tonight. Obviously coming from Napier Uni. We're delighted to have Professor Bill and Liam again. Delighted to be back here at Napier Uni. So thanks very much to Bill and the team for having us tonight. And thanks everyone for coming along. Okay. So just to say thanks again to usual partners, Product Forge are here tonight. We're not getting live streamed, but there will be a video available later. Thanks to MBN Solutions for organising beers and pizzas as well, which went down a treat tonight. Thanks, Willie. So just before we start, just want to let you know about the meetup next week. Something a little bit different. We've got Trevor Jones who's here tonight. Trevor? There he is. So Trevor Jones, next Thursday, 25th October, we're doing something a little bit different. Trevor does crypto-inspired art, so please check it out. And come along next week at the Dash Street Gallery in Edinburgh. And Trevor's got some leaflets as well, which he's got in his hand, he's got over there as well. So please come along to that if you're interested. Also, a lot of you will be aware of ScotChain, so only 3 weeks to go. So tickets are nearly sold out. So please, if you're interested in coming, please get your tickets before they all disappear. Now we're doing a little bit of a promotion tonight. You might have seen Tiffany from MBN. Where's Tiffany? So she's walking about with a blockchain bucket. So if you can take a raffle ticket. Now some of you already done it. You've got some discounts on tickets. So there's free tickets in there as well. So if you have one and you've got a discount now, please email. The email address is tiffany@mbnsolutions.com. You can do that right away as soon as you can and get your discount code. Alright. So I'll start tonight now. I think we've got Liam starting off first. Yep, so everyone please give a warm welcome for Liam Bell.
Okay, it was great to be back again. I did this last February, in which we talked about what they were doing in the healthcare and then kind of teased the launch of the lab. And today, well, I'm going to talk to you about what it was like to build that lab, because it was definitely an interesting experience. Sorry. Yeah, apologies for that. So, what I want to talk to you tonight is about what it was like to actually build a blockchain-focused lab. Now, working in a university, we do have a lot of bureaucracy, so building it was a lot more stressful than I originally thought it would be. And to be honest with you, one of the things that I do want to do over the next 3 years is build a time machine and go back and stop myself from saying we should have 4 events in a row, because that was probably one of the most stressful weeks of my life. As you can probably see there by... we're going to kind of go through a slideshow, almost a holiday pictures, and again, you probably don't want to view it either, as you don't in a holiday photo slide. But there we kind of are at the end of having built the lab, and let me tell you, it was certainly an exciting one. And of course, there was the launch event, which some of you would have been to, some of you have obviously met me before, in which we had such exciting VIPs as Kate Forbes from the Scottish Government. We also had Joanna Cherry from Westminster, our local MP, and a whole host of VIPs really speaking that were fantastic. It was a great night. Some people indulged a little too much in the whiskey, but there was enough left for my office afterwards, so I can't complain. And after that we were at Scotsoft, which Scotsoft was a great experience because we actually got to go out there, we got to talk to people about what we were doing, and we got to hand out the swag. Some of you might actually have some of the t-shirts from that week. It was brilliant, and I honestly, after the planning, that's kind of when it became more exciting. Don't worry, this slideshow will be over soon, and I can actually start talking about the real work that we do. After that we had the conference. As those at the conference probably realised, I decided to riff it. I found out I was doing a presentation half an hour before I did the presentation. And so I riffed for a little bit on exactly what is wrong with identity and various other things that I decided to rant about on that occasion. and Bill talked about building the future. We had a great lineup of people talking about various blockchain use cases, various partners that we have in the lab in digital voting, in non-fungible tokens, as I keep being told to pronounce it, and even in side channel attacks for IoT. And then we had the hackathon, which was an interesting one for me, because I've put on hackathons before, and they've always been very well attended, this one a little less so, but we had some really exciting ideas actually. So we had identifying refugees. Now that's actually a real problem in the identity sphere, obviously, because when you have no documentation, it's actually very difficult to say who you are. And they had really interesting thoughts on reputational based staking, where someone has the ability to say, because people trust them, that this person is who they say they are, and you build up that kind of, I guess, credit score of identity. Really interesting work they were doing with us. But I'm going to end the slideshow now because, oh actually, never mind, I told you there was one more slide. And that was our first day at work, and one of the best parts about this lab actually is that we have experts from a whole lot of areas. We've got experts in cryptography, like Professor Buchanan. We've got experts in the Internet of Things, AI, and in secure software design. We have a wide range of academics involved in this lab. It gives us a huge breadth of experience, not just in the blockchain space, but across general computing fields as well. So I guess the next part is to talk about the kind of things that we're working on at a very high level. The research questions that our grade 2 of PhD students are approaching, and indeed some of the stuff I'm approaching as well. I mean, the biggest focus of the lab, the biggest focus of the lab is, of course, identity, but there are so many aspects to identity and so many aspects to the data that makes up who we are, and moving that towards the decentralized world where it isn't controlled by people like Facebook, Apple, and I won't rant on that because those who were at the conference certainly heard me do that long enough. But the ability to prove that your data has been deleted, the trusted governance layer that allows you to say, as they do in Estonia, that this person has viewed my data at this time, why have they done it? And now, the thing about Estonia, and I don't like to go on about Estonia, because they're a country of 1.7 million people, they can live off a centralised service. It does not scale to the size of country that we are here, but we can build on that model as we're doing in the healthcare sphere with the Digital Health and Social Care Institute, to build a truly decentralised model that actually scales to the size of country that we are in and that most of the rest of the world is. It's one advantage we do have in Scotland though, is that we're not as small as Estonia, but we are still a small country, and so we can pivot a lot faster than larger countries can. Same thing applies to companies, same thing applies to governments in theory. But we're also looking around the execution of smart contracts in trusted execution environments, agent-based modelling, privacy-enhancing technologies. So one of the big parts about maintaining privacy is that we still want to be able to do useful things with that data. And so using techniques like homomorphic encryption, we actually can do interesting things while still keeping it private and be able to do that big data analysis. A great use case being Microsoft Health's work around detecting risk factors for liver cancer. So they've just got large anonymized databases that they can then search over without giving up the privacy of individuals, but still allowing us to prove patient outcomes. And that's the kind of world that we want to move to. So the other part is, I'm a big believer that one of the biggest roles of universities and of research is to feed directly into industry and also to feed directly into impact and get out there in the world. I've never been the type of academic that likes to stay in the lab and write papers. I know that's what I'm doing right now. But I'm a big believer in knowledge exchange. I think it's extremely important for what we do. So I'm going to go through some case studies of various use cases that we're working on. Some of the people from these companies are actually in the room right now, Bob. And so I will move on to that now. I think it's really important that we talk about the real industrial impact that this lab can deliver. And the first kind of use case we do look at, though, is obviously, it's in the name, it's digital identity. We have the ability for this self-sovereign, decentralized system where people actually have control over their identity, where you can, for example, give minimal credentials. So, for example, when I go to the bar, as I regularly do, why do I have to give up my address? It's all of my ID documents, but the person at the bar doesn't care about that. What they care about is that you're over 18. They actually don't care what your age is at all, as long as it's of the legal age. So why should we give up that data in the slightest? And certainly going back to what I talked about earlier around Estonia, that ability to actually have that granular control over who accesses your data and when in the public service world is important, but even more so in the private world where, I mean, their motive is to make money, and that's not always ethical. Facebook, Cambridge Analytica, etc. People didn't know this, and it's, part of that is because we have privacy policies to decide what people do with their data that are 100 pages deep. I don't read them, and I mean, I do research in privacy. I don't read privacy policies because it's all legal jargon designed intentionally to confuse us all. However, if we actually had a much simpler view of when data was being used, then we have a much greater consent model around building these systems and around actually getting this for the future. So I came to you today, so yesterday I was in Westminster Palace at the All-Party Parliamentary Group on Blockchain, on which I advise, and they asked me, what is it that I think is going to happen to the Facebooks of the world? Because why on earth, if you actually have control over your data, would they continue to provide a service for free? And my answer to that was that, well, it was never free. Because the fact of the matter here is that there is no such thing as free. Google, Facebook, Amazon, Amazon to a lesser extent because they take obvious transaction fees, but Facebook and Google especially provide you their service because of how valuable your data is. I personally don't think that we'll go to a world where people are just making cash in hand by being given money for their data. I think we'll move to a world where you actually figure out the true cost of using these services. So you will use Facebook and they will use your data, but at least you will have that consent and understanding of why they're using it, what they're using it for, and to what extent they're using it. I think that's the kind of model that the world will move to, because I think if they don't have the ability to extract your data, why are they going to give you a free lunch? So another case study that I want to talk about is actually around supply chain. So we have a few supply chain use cases because blockchain lends itself very well to supply chain. We've got projects in the healthcare sector, projects in food and drink, projects even in construction, because actually, technically speaking, all things are provenance. And by that I mean that even when you're tracing data, that is still the supply chain of that data, that is still provenance. And so with medical devices, I've got a few bullet points here because I'd actually rather talk about it than have you read this. But we're working with Spiritus, who Bob is here today representing, and we're building in our simulated skill centre, which is our virtual hospital in Sight Hill, the capability to do end-to-end medical device supply traceability. This is all stuff that's available in the PR, very interesting stuff that we've been working on for the last just over a year. And the gains to the public sector of actually able to do that traceability for medical devices are pretty clear, because there's huge problems in the supply chain already with fraud, so devices being stolen, with devices being lost, devices being repurchased. This is all stuff that people have looked to solve with the with, for example, RFID, but the problem is the focus specifically on the hardware, which is actually not what's important. It's about the data and capturing it in the right place and being able to feed that analytic information to you. Nobody, I hate to toot Spiritus' horn, but nobody does it quite like they do. So the third case study I wanted to talk about was actually in the construction sector. Now the construction sector has a lot of problems with it, as I don't know if we have anyone here from that sector, but essentially what we're doing with them is we're building a kind of MOT for buildings. This is the kind of stuff that came out, you may have seen the Scotsman article about it, but it's about the MOT for buildings, because a lot of the problems that there are in construction, first of all, it starts early, because it starts where an architect designs a building, says these are the materials you should use, and then a building company says, oh, I could bid a very low amount for this to make a lot of money. But then they get to the end of the project, as is quite often the case, and they realise, oh, we don't have enough money to deliver this project. And so they cost cut, and so they get lower quality cladding, lower quality insulation, lower quality windows, and actually there quite often isn't a match-up between what the architect decided there should be and what there is in the end, because at least my experience of talking to architects is, despite it being a legal requirement to use BIM in a lot of cases, they either do not or feed it out to third-party companies. A great anecdote on that was that I've spoken to quite a few who are not even capable of running the software. It's too intensive for their hardware, despite the fact that it is a legal requirement that they do it. there are very few good, proper use cases of BIM. The oil and gas sector does it much better, but one of the best outcomes for it was actually Queensferry Crossing, where they met BIM level 2 quite well. I'm not going to get down into the details there, but we were working with some public sector partners who unfortunately at this moment not allowed to name, around doing this exact building MOT, both for tower block type buildings, but also for public buildings like police stations, fire stations, schools, those types of buildings. So the fourth one that I want to get onto is another supply chain one around food and drink. So we're working with Academy, I believe Gary might be here somewhere, and now that's an interesting one because there are so many problems in the food supply chain, one of which is around ethical consumption. We all saw the horse meat scandal. Now my personal take on that was horse meat is actually better than beef, but you know, as a society we choose not to eat it, and that's just how it is. But on the other hand, it also creates great economic value because if you can prove that somebody is from Scotland, the research from Interface, who are very focused on food and drink related outcomes, says that you get a 15% premium on Scottish salmon, on Scottish whisky. I mean, I don't know why you drink any other kind of whisky, but that's beyond me. But it also allows you to actually see some of the problems. So, for example, a lot of the tuna in the UK, we have quite a lot of understanding. There's quite a lot of illegal fishing going on in the Philippines, which is where we get a lot of our tuna from. But I want to point out when we talk about case studies here, because I'm sure I will hear it from you later on, is of course blockchain is not a panacea. Where you have that interaction between the physical world and the digital, that creates problems. So, for example, there is nothing stopping you from moving an RFID sticker from a fish to another fish, or a package of fish. So you have that real world problem. There are some ways of solving it in whisky. You can use chemicals to give somebody a unique identifier that you cannot remove, and even if you put whisky in the same bottle, which is actually a real problem in importing to the Far East, it doesn't make a difference. But the problem is that nobody wants chemicals in their whisky. The same thing about edible, invisible QR codes, which is something I talked about census with recently. But the problem is, people are too risk averse to the thought of eating something that has an identifier on it, that again, these kind of things cause problems. What I'm going to do next, because I don't want to take up too much of your time today, is to talk about what we're going to do in the future, which is from today, we're working on grant proposals with a variety of companies in other use cases, worth a couple of million, a little bit more even, around the types of supply chain use cases, some of which we've touched on vaguely today, some of which we haven't. And we're also always looking for new research partners, because as I said at the start of this, I think it's essential that the research that we do in the lab gets out there into industry and has an impact in the real world. I'm not a believer in keeping it in the ivory tower of academia, personally. Now I'm going to pass over to Bill now. I know this was a little bit shorter than intended, but I've been very busy this week. And so Bill's going to give you an understanding of the technical side to the future that we're going to build, specifically around the stuff I talked about, privacy enhancing technologies. Usually I would take that, but time. Right, okay?
Thank you.
Thank you very much.
Okay, thanks Liam, and it's great to have such talented people in the lab. We're very lucky. That's the advantage of being in a university, is that every single day you come across somebody that's just so smart and really gets where you want to be, and that's the great thing about working with universities, is to have that potential. So I'm going to take a kind of random walk. I'm a teacher, so I want to teach you something, so please excuse some maths. I'll tell you when they're going to occur, just in case you want to blank out or something. Oh my God. I will do some elliptic curve. No, God. The professor's going to give me homework. But yeah, there's a bit of homework at the end, so that's good. Okay. So the title of this, and you never know what you're going to talk about when you get asked to do these things. So I thought, well, go back to Bob Dylan, because it all goes back to Bob Dylan. I should have brought my guitar, I know that. You wouldn't have liked that, I can assure you. Especially when I start to sing.
To the bone. If your time to you is worth saving, then you better start swimming or you'll sink like a stone. For the times they are changing.
Second verse. He does 15 verses, you do know that. Come riders and prophets.
Critics, you prophesize with your pen.
Come on, sing. What do you mean you know the heavy Bob Dylan?
And don't speak too soon.
I had enough drink yet.
And there's no telling who.
That's it. So there are words in there that I think are very important, and they will say that you better start swimming or you'll sink like a stone, because the times they are changing. And I think we are at such a wonderful time, and we're really changing things as we go along there. And it's worrying, because we see our existing world crumbling like never before. The risks to our society are almost by the day. We could bring down our whole global finance system in a second. One hack and the SWIFT network, this one here, could be brought down, and we're all in financial ruin. This was one hack, 81 million from Switch. It happened in the most unfortunate place in the world, in the Bangladesh central bank. Sounds very grand, but it wasn't. They had second-hand switches, no firewall, no 24/7 SOC with graduates running the place and so on. This was a very basic infrastructure. And they nearly got away with another 20 million, but they couldn't spell foundation. There you go. What kind of cyber criminals are we dealing with here? Get yourself a license for Grammarly. Get on Google. Foundation doesn't work. How do you spell foundation? Has it got an A on? I think it's got an A. You joker, you. You just cost us 20 million. That's the error correction on SWIFT. The only thing that it checks is that it's got a valid name. That is scary, if you ask me. And this one happened. Does anybody know what this one's related to? Ticketmaster had a lovely little integration for their site. You can speak to a non-human and they'll make some sense. And Monzo phoned them up and said, have you got a problem with your site? Everything's fine, it's all good. Well, 70% of our frauds are coming in from Ticketmaster, and you've only got 1%. I think you have a problem. Oh yeah, got a problem. The JavaScript was integrated, and the JavaScript was running off this code that somebody had run, and it was sucking off all the credit card details for users. Who designs these systems? Isn't that a kind of fundamental thing? It happened with the BA. This is the BA site, got a D grade. That's not very good. That's must do better as a teacher. And this is the script for. So they got into the BA, British Airways, and they were running for three weeks. At least 350,000 credit cards were stolen. Details. If you look here, the bit I found the most funny about this is that these hackers are secure. This code sends whatever you post onto the BA site, so every single card that was put in was hacked. It gets sent to www.https baways.com. These hackers are good, aren't they? They set up their own certificate, their own secure site. And the incident report, you get phoned up on a Friday afternoon. I always can tell it's got no caller ID and it's the BBC or Sky. And you've got to very quickly see what's actually happened. And it was pretty obvious it was in the browser because of what they were actually saying. And it was the JavaScript integration. They had hacked into the site, spear phishing. They had modified the JavaScript to add BA didn't detect. It should be standard tripwire stuff. And it's quite worrying because Instant Response said, it's okay, your passports are all right. What did they just say? Your passports are okay. Well, that's good, because that's really what I'm worried about. My credit cards, is that okay? Yeah, I think you should change it. You had to scroll down to frequently asked questions. Right down the bottom it said, maybe you should change your credit card details. My advice was, change your credit card details right now. Cancel your cards. You've been hacked. It's not your fault. But the incident report just didn't highlight that at all. So make sure you respond properly with your incident. Okay, so every single slide. I was in Dublin the other day and I got scared to bits because somebody told me that the UK won't be compliant automatically to GDPR, and that sent a cold shiver down my back. So I don't want to depress anybody today, so let's not talk about that. GDPR is where we should be and where we have to be if we have at least one EU citizen. In fact, if we're trading anywhere in the world, GDPR is the way that it should be done. Encryption is standard, citizen rights, instant response, 72 hours, and pseudo-anonymity. I say this every single time. If you can tell me what pseudo-anonymity means, I can't even say it, then you're a better professor than me. But maybe we can talk a little bit about that. So now that's what I call the 20th century. So I think we're in the 20th century. Wow, great, got all the music back again. And the reason that we're in the 20th century, why do we use passwords? Why do we store them? Why do we pass them? Zero knowledge is there. We don't have to store hashed passwords anymore. 8 characters, I do a demo to students. 2 seconds to crack every single 8-character password. If you can use squiggles or anything on the GPU cloud, costs you $10 an hour. They're all gone. 9 characters within a day, 10 characters within a couple of days. Passwords are finished. Hash versions. Salt. We use salt. But the hacker can see your salt. They can see your, hello, there's salt's there. We'll get rid of the salt. If you get rid of the salt, then you're not going to get that password back. And with the GPUs, you've got 4,000 cores. You can buy a GPU cloud instance with 16 GPUs, and you can run it up. Hackers have been able to take 3 photographs and end up with the same hash for each of them. That's the processing power that we have. So why do we do that? Why do we do wet signatures? Why is that still a thing in this century? I may be in a minority here, but I cannot understand why my squiggle, it's a good squiggle, you must admit. That's my sawtooth squiggle. That's when I've got a bit of time to do something. Most of the time it's whoosh. But I've got a swoosh at the end. So we're doing research here about that swoosh. That swoosh, you do a straight line, swoosh, and you can spot who it is. So I just find them so funny. And anytime I put my bank details in with pen and paper, I go, this is crazy. This isn't right to do this in the 21st century. So if you want to see my signature, it's on Twitter. Okay, there you go. I think that's what my signature looks like. I couldn't replicate that, but I'm sure you could probably do it with Inkjet. And there's the Nagme signature there if you want that in there too. That was posted on Twitter. So it's not a big secret, is it? And even still, who knows that is your signature? If somebody verifies your signature, have you ever done that fraternity? I get my wife to do it all the time and I get told off. You can't do that, she knows you. Yeah, I know, but she knows me better than anybody else, I hope. Can I get my kids to do it? No, they know you. Well, I know. And they got to get some strangers. So I usually go down the street and say, well, I'm a professor. that's me. And I've got to be told by a solicitor to show my signature. So it's a crazy world, and I don't understand it. Why do we fill in forms? Forms are forms, no matter if they're on paper or on electronic. That's just the same thing. Again, we shouldn't have to be filling in forms. We shouldn't have to be putting in a date of birth and everything again. And the crazy thing is that you press a button to put your signature in. Have you ever done that? I don't understand that. It puts your written signature in there. You go, what credibility is that? I'm a crystal professor. I want proper keys involved, and I want certificates, and I want to make it difficult. I want PKI. Why do we have to fill in forms? Why do we centralise everything? Aren't we building a world where all our data is just put in one place? If that data was attacked or taken down, we're stuffed because it's gone. Why can't we replicate and decentralise? And then, why can't I trust email? Oh, Microsoft, please, for goodness sake, you've been at Outlook for all those years. Why can't I sign it properly? And you bar my emails if I sign. What's your problem? I know people want to snoop on your emails and they don't like that kind of thing, but surely there's a better way than email. And please, government, recognise me. I know that you like getting my taxis, and I know that you like my parking fines and stuff like that. But hello, I'd like to say things, and I'd like to find out about things. Why can't we have an electronic record, health record, that just shows you what your kid's immunisation is? I mean, that's pretty simple. There's nothing to that. Stick it online, and we can look after it ourselves. So it's a world that needs to possibly change. So we need to ask ourselves, what is ownership? So this is my car today. Hopefully I've not left the lights on. I'm a bit worried now. I think my car light's go on for a wee while. I don't know. Don't look at that number plate, okay? That wasn't meant to be seen. I own that car. Anybody else own that car? No? Good. I might sell that car. But that car isn't happy because I'm the owner. Because you see, that's repressive, Bill. You own me. I'm a slave to you. But I own you. I think I own you. I have a bit of paper somewhere in the drawer that when I come to sell it, I get some. I have no idea. You get something to fill in, you send it away, and it's really confusing. I used to go to a dealer or something like that. Not that kind of dealer. That's coming later. You didn't think you'd see cocaine in this presentation? You shall. We will cut that. You will see cocaine later, okay? That was a waste. So what is ownership in this digital world? What really is ownership of something? What's consent? That's a really difficult thing. People don't understand. They don't get it. Well, consent is just clicking a form. I've sent an email, you've consent. T's and C's said that we can do anything. That's fine. That's not consent. That's not consent at all. You're using all my data for your purposes of making money. I don't give my consent to that. And then we need to say, there's a country border. Why do we even have borders and things anymore? We all live in a virtual world. Who cares about physical? Sorry, I'm probably showing my my viewpoints here. But why should we have borders and hard things that say it's legal there and it isn't legal over there? And if I trade over there, then that you're doing that law. I don't understand that. That's a strange world. And then if it's going to show, my car wants to be seen, it doesn't want to be covered up. Whose laws do I comply with? Whose systems? And and it's typically wherever the server is and where the company is registered. So oops, that's not good. So that's just crashed there. So let's see if we can get that back. And why does money, fiat currency, exist? I have no money. I go past people in Edinburgh and I'm really sorry. I honestly have no money. And if I had money, I would give you whatever I had. Honestly, I'd let me go and get to. I have no concept of physical cash anymore. I do everything with my phone. So why do we even have is fiat currency a way for countries to control us? Is that what fiat currency is? Where if you have a fiat currency, you have control, you have power. And what's my rights to privacy? Where's my health record? And why won't my council speak to me? So, I've always struggled with the term evangelist. I got cybersecurity evangelist of the year. That was nice, but I said, could you just drop the last bit? I'm not religious. I never have been. I'm not an evangelist. I'm an academic. I have rational thought. I look at everything. I can't sell something and stick with it. I could never be a politician ever in a million years. So the evangelist term.
Healing, go into those knees. Arthritis, go in the name of Jesus. Tumors, go in the name of Jesus. That one calling with lupus. Lupus, you foul devil. You bow to the name of Jesus. Lupus.
Oh, sorry. Sorry about that.
Healing, go into those knees. Arthritis, go in the name of Jesus.
I should bring along a hanky.
Go in the name of Jesus.
That
one calling with lupus. Lupus, you foul devil. You bow to the name of Jesus. Lupus, you bow to the name of Jesus. You go in Jesus' name.
So that's an evangelist. and
Pastor Creflo Dollar of the World Changers Church International facing harsh criticism after starting a fundraising campaign to buy this $65 million luxury private jet.
If I want to believe God for a $65 million plane, you cannot stop me. You cannot stop me from dreaming.
Okay, so that's an evangelist. If I told you to buy a £60 million jet, I don't think you would follow me at all. So I rationally will look at everything. This guy here is a bit of an evangelist. This is John McAfee's tweets. He tweeted things, the stock price, the value of each of the cryptocurrencies went up each time. He has admitted it. He's a kind of wacky guy, isn't he? He's a kind of wacky guy. And if you don't get him, that's his personal message for you. It's wonderful to be in an industry with such characters and wonderful people. I don't know how many guns he has in the back of his car, but it's quite a few. So do we have a trusted public sector? So I got this, I don't know if you're a citizen of Edinburgh, I got this saying that you need to register, here's the ID that you need. And then I click on the website and it tells me it's untrusted connection. It's as if Chrome never happened. It's as if 85% of the population use Internet Explorer. Does anybody here, God, it's embarrassing. Anybody here use Internet Explorer?
Well, man, you said that.
Not when I said that, you don't get rid of it now. So then you go to the site and you get that, and then you go to the site, I think this is so funny. He said, you go to the site, and please be assured that this email is genuine. I don't know if anybody sees the flaw. I, the scammer, are going, back in the net. He's just about to send an email out with this link. Close it. The email's genuine, so everything's okay. I'll just put my details in there. And so that's the bit to be highlighted there. Please be assured. I mean, the website isn't even secure, but that's another matter. Please be assured that this email is genuine. I mean, that's 1980s comedy. and you really worry that, that we're doing this. So this is the kind of thing I get. This is so I do networking at the highest levels. This is from the Deputy Secretary General of the UN. Okay, I don't think you're worthy enough to listen to this presentation. And he promises me quite a lot. I don't know if that's 1.2 trillion, but it's 1.2 million, and everything's fine. He does actually exist, and then he's there. So that's the kind of thing I get tricked with. So if I get tricked with that, then I'm going to get tricked by the other thing that we saw there. So we need to understand what trust is. And trust just now is about signatures. It's about us doing our signature like that, us doing our signature like that whenever we meet. But the thing that most people don't get with this binary debate about blockchain is that it's past. Bitcoin was old. That was the first one, and it wasn't very good. And it's running, but it's great because we can learn about it. But the second generation block is a smart contract, and now the third generation gives us consensus in a minute. But we're still trying to argue Bitcoin. It's going, Bitcoin's rubbish. Yeah, we know it's rubbish, but it's there, and you don't have to buy it if you want to. But my goodness, with these things, we could build a whole new world with consensus in a minute. Why does it take a bank 3 days to clear your money? Because there's a whole lot of bits in between that take in there, a bit of transaction costs and things like that. So the possibility is there that we can build a new world. And again, there's this, oh, it's not fast enough. There's a whole lot in there, and it's getting faster. And if you really want it, if you really trust it, then Ripple is competing closely with, you don't have to buy the cryptocurrency, but the actual method can compete with Visa. As we've seen, the SWIFT network is hardly the most secure network in the world. So it's a changing world, and we need to understand that it isn't just a binary debate. So, unfortunately, I'm going to teach you a bit of crypto. So you can go to sleep now for a little while. And it's got nothing to do with crypto, but I thought we'd just play some nice music for a little minute. Any German speakers in? Good. You don't want to say to the rest of that. So that's got nothing. And our viewpoint is that crypto is the answer. I didn't wear my crypto t-shirt because crypto is seen as cryptocurrency. I see crypto as cryptography. And I think it's a core thing that will build a new trusted world. For Alice, which gets there. We built a world of trends, and we use trends, but it's not working in terms of PPI. So crypto, if you want to know the basics, symmetric key, the workhorse of the industry. AES, we use the same key on the other side. Use key exchange to be able to send it over. It's public key. That's the most important thing. It's this public and the private key that I'll outline in a minute. It's this thing here that was created in the 70s that's now the king of the hill, and it will be the true focus for identity. Hashing, we just hash, simple hash, we take a message and we create a hash of it. Public key, you're not going to get this. It took me a long time. I'll say it anyway. Maybe someday when you're having your breakfast or something, you go, I get it, and then you'll lose it for a while. Our students are like that. They go, oh yeah, I get RSA. I've lost it again. Honestly, the number of emails that I get, I just don't get RSA, I don't get RSA, I'm really worried. Oh, I get it. And the next day, oh, I've lost it again. But they get it back in the end, hopefully. Elliptic curve, I'm going to really bore you here. There's a point on the beautiful elliptic curve. X squared is equal to y squared plus 7 is one that the NSA can't crack. Okay, don't tell them about that. Because there is one that they kind of pushed. that they knew they could crack. This one doesn't. So we take a point, an XY point. I can hear the breath. It's like being back at school. This is an XY point. Remember at school they taught you about XY points? That's an XY point, okay? We create a private key, 256 bits, and we create a gradient. Remember at school they taught you about gradients? You create a gradient, and at the point at which it touches the curve again is your public key, an XY point. 256, 512 bit, that's your keys. That is the most wonderful thing at the current time. Okay, when quantum computers come along and you're watching this video in 5 years' time, they'll go, look at the professor, he had no clue. I have a quantum computer on my desk, cracks, all that rubbish. So that's where we are just now, and it's taken over the world. It's the key to the future. Sorry, a bad pun there. If you want to see what that looks like, oh God, numbers and things, that's what your public and private keys kind of look like. There's the equation here. It's a prime number. It's all prime numbers. It's all mods. That's what they actually look like. So we must ask ourselves, what is identity? What really is your identity, and how can you lock that down to be completely unique on the internet? So I did some searching around, and the images I found were these. Honestly, these were the first ones I found. That one, that one, that one, that one. All people with their ID cards. Can anybody see what those ID cards are? What are they? So yeah, it's marijuana ID cards. I think we get them in the US. It seems to be quite popular on the internet. No idea why. No idea why. Doesn't give you a license to grow it, okay? You've got to pay more money for that. I'm not joking. I've got licenses here if you want to fill them in. Cut up. I love this one. I love this one. Look at that guy's face. That's like the before. I've done it before and after. I like to do that guy. So that's examples of ID cards that we have. So what is ID? What really is it? And we all know face recognition could be hacked, fingerprint could be hacked, handprint could be hacked, that's fine. What else have we got? Oh, passwords. The most popular password, do you know that? Every single time, it's right up there. 1, 2, 3, 4, 5, 6. People are so lazy that they cannot think of anything more than that noggin donkey. You've seen the Simpsons episode where he does yes, yes, yes all the time. 1, 2, 3, 4, 5, 6. Or 1, 1, 1, 1, 1. That's too much effort. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go to 8 and I'll never think. 1, 2, 3, 4, 5, 6, 7, 8. I caught you. People, they're but the true identity is a private key. 256-bit key. This is the number. If you do 2 to the power of 256, that is the number of keys that you have. So your private key is unique. In the whole time of the planet, there will never be 2 people, hopefully, that will have the same key that they generate. As long as it's random, okay, I know that's a difficult subject to do, but as long as it's random, that is unique. No hacker in the world has the computing power, not even space aliens, I don't think. Okay, they might have some crazy computing Xbox or something like that, but it's just not going to happen. So we prove identity through public key. We do it through signing our data with our private key, and we give it to Bob. Bob proves with our public key, and the 2 keys work magically together. Don't ever give anybody your private key. If you lose your key, it's gone. Your money's gone, your identity is gone, and so on. So you need to make sure that that is ultra secure. So I get asked all the time, how should I store my private key? And I say, a paper wallet. So there's me talking about wet signatures, and I say, store your key in a bit of paper. That's the best way to store a key so it's not actually online. So our smart cities have got the potential to be able to create something that provides the citizens with a new way of using data. So it's really at the lowest layer. You've got all your inputs, your outputs, then define the services that you're searching for, and these are the basic outcomes for any city. I really love London open data because their user interface has KPIs. You can see straight away what they're doing for poverty, unemployment, and so on. I'd love to see Edinburgh have the same thing. I could go to a dashboard and see how pollution is being dealt with and so on. So cities really should be defining KPIs, and citizens should be able to see exactly how the data has been used to be able to assess these things. So there are many different possibilities, but pseudonymization must be a core part of this. And we need to create what our trust and governance infrastructure. So in terms of a true trust, you have digital trust, and users just hope that that all happens. And there's nothing I can do as a crypto professor to say, this is AES encryption, the best encryption. I could give you a little coloured padlock or something like that. There's very little that you can do. It's got to be trusted that what you're using is good crypto underneath, and good strong identity and rights. The core of what we need to build is strong governance and things that people want to actually use. So the human trust must come with digital trust. That's our old world. Yuck, 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 yuck. And that's our new world. Much more integrated, much more understanding of the citizen as an entity as in that, but not as a spying network for the citizens. It will be rejected again in the UK if we go again and say that this is a way to track citizens. It must be a Finland or an Estonia point of view for that. And a healthcare system is very complicated, but it's just code. You could code all the interactions that you have. You can have simple smart contracts to make sure that all the payments actually happen and everyone knows what's going on and how it all works and payments actually happen. And then we can have the bit in between, which is the trusted bit, and we can push data to the citizen, and we can make sure that their healthcare infrastructure is also being able to work, because they work in certain ways. So what we envision a future healthcare system will look like is that if Bob has type 2 diabetes, he goes and sees that clinician, they sign something, that's an attestation, it then is associated with a citizen and will run smart contracts so that he can now get cheaper medicine because of his condition and so on. I should, at the age of 60, be able to walk on a bus in Edinburgh and not have to fill in a form. The bus should know, got happy birthday to you, shut. Shut. I get free bus travel, yeah, that's fine. That can run off a smart contract. That's not a difficult thing to do, but I should have control as to whether I want to do that or not. And things like repeat subscriptions can just happen, and we can make sure that this all works and it's all identified. But the core is having the private key for the citizen and having control that they allow these things to actually happen. So a smart contract might look like this for services, and we just tokenize. So why do we talk about pounds and dollars and so on? Why don't we just say it's a certain number of health tokens, we cash them in, cash them out, and we can write our contracts in that way. So I'm not going to talk about Estonia. I did talk about it there, but that slipped. I'm not going to talk about Estonia. There you go. First time ever, I'm not going to talk about Estonia. I'm going to talk about Liechtenstein. What? I'm going to talk about Liechtenstein. Anybody know where that is? It's not a geography class, so don't worry. And Liechtenstein is the most advanced place in the world that I've actually seen. Okay, so this is the old banking system, this is the new one. I went to Jersey to give a presentation, and Jersey is a very trusted finance sector, but they're looking at tokenization for their economy, but they've got to make sure that they don't sully their reputation. So we've really got to watch when we're moving towards a tokenization economy that we could be causing problems and scams and so on. So some countries around the world, and Liechtenstein is one, that actually has drafted a blockchain act. And you go, yes, come on UK, come on Scotland, come on Edinburgh, let's start the talking now, because these guys are getting it sorted. They're getting lawyers to talk to techies and crypto guys, and it's all kind of going to work, hopefully. And what they want to do is to enable a real transformation of blockchain systems while ensuring legal certainty, thereby opening up an application for a full potential of a token economy. In 5 years' time, when somebody watches this presentation, they go, yeah, that's happened. Token economy happens. But now, Liechtenstein are the first to actually look to create that foundation. So what they define is there's not just one token, there's 3 tokens. Payment token, and that's what everybody understands. We get a security token, that's your ownership of something, and a utility token. So when I got on the bus in Edinburgh, I used a utility token because I have a token on here that I just pass to the driver. So those are the types of tokens. And what we need to understand is that how do you own that? How do you give it possession to somebody, and how do you transfer it? So the legal industry needs to start to talk about these new things called tokens and see them in the same way as we would money or possessions. Buying a car means that I have a token for that car. You cannot say that I don't own it because here's the token. I have it now and I'm going to pass it on to somebody else. There's a legal transaction that will make that happen. So simple. And what's stopping us from just rewriting all our laws, replacing things with tokens? It just makes so much sense. And the core of it is that you have your private key. The private key will define who owns something. You might have a custodian who looks after your private key for you. Maybe it's a solicitor that will take over your tokens that you trust, and they will do the transaction for you. But the whole concept is it's not necessarily you that has that. So these are if you're interested, these are what they've drafted. Go and comment if you want, and I'll not listen to you because you're a Scottish citizen. You have no rights in Liechtenstein to tell them what to do. They're a confident little country, and they can go ahead and do it. And we're a big country, and we're a big ship to turn around. But I would say if you believe in this, then why not tell your government that we need to create a tokenization world and create this, put digital assets on. I mean, who knows who owns a painting? If you have the token for it, I can prove a crypto way that I actually own something. Very little can be trusted apart from that. So what does a tokenization world actually look like? Well, we've tried this before, and we've tried to fake things by giving fake numbers, and we have a surrogate number in our database, but it's really easy to guess that and to link that back to the person. So surrogate IDs have never really worked because they can be easily traced. A token world is a much more secure world that we just cash in for a few tokens, we spend them, and the maximum we're going to lose is those tokens. So we do it at the casino, we wouldn't walk in with £1 million. I know you're not going to do that, but we wouldn't walk with £1 million in your pocket. You would get some tokens, and cash them in and walk about, and you get more tokens usually. And we're quite happy with that world. We just deal with tokens. Low security, high security. So a tokenization world actually starts to make everything a token. So everything here is highly secure, and we just have an exchange that deals with the tokens back and forward, and everything is anonymized here, where we have sensitive information there. So a lot of banks are moving towards a tokenization infrastructure, where you set up a tokenization server, which is highly secure. Token comes in, gets processed, it asks questions about the token, and it returns back from here. The personally sensitive information, if you need it, is in here, and never here at all. In this way, you can guard your whole data infrastructure. And this is the way that we need to move. So this is Visa's best practice for tokenization. So if you're implementing that, that's the crypto that you use. You should be running all that kind of thing. And hopefully, if you're a bank, you're kind of running that anyway. But this is like Fort Knox in here. And you make sure that your tokenization infrastructure, the place that keeps the sensitive information, is highly secure. In that way, we can create fake tokens. So in this case, we trick the whole of the credit card infrastructure to take this fake CVV number. It's not the real one, it's a fake one, but we get a token back which pretends to be the original, and we pass that on. The point of sale is okay with it because it looks like a credit card and so on. We go to the merchant, and then they take the token back to the tokenization server and says, does Bob have enough money in his account? Yeah, he has, that's fine, and it's paid. So we give away too much information, and we really should be just creating tokens for our data and hiding it. And this is interesting because this is format preserving encryption. You can have a look online to see how this works, but we create a nonce value that if you want, the user can have it on their phone and they can have control of it. That then encrypts the strings to produce something that looks perfectly valid. So format preserving encryption allows you to say, I want something that looks like a credit card. In this case, that's a fake credit card, but to reverse it requires the nonce to go back. So it's really interesting technology, and I think that's, to me, the next step before we go to full blockchain, is towards this type of thing that actually starts to tokenize, but still is allowed to use SQL and all the other systems in there. This is honey encryption. If you've seen it, the problem with encryption is that I keep trying keys and it gives me an exception, and then all of a sudden it doesn't give me an exception and go, I've got your key. So honey encryption allows you to not create an exception every single time, and that you'll get a valid credit card coming back when you try each key. So the hacker cannot tell that they've been successful in their encryption. So this is honey encryption, and it's an interesting method. Just now, what we do, I don't know if you know, but we all have a KI number in Scotland, and it's not a big secret, and every single medical record has the KI number on it. That worries me like anything. Basically, every single medical record, and they want to create a unique ID for everyone in Scotland. And once someone knows your ID, they'll be able to trace everything across councils and things like that. So it's quite worrying that you have that. In the future, what you'll have is that the user can store a salt value. We take the user's ID and we hash with salt, and we hash with salt, and we hash with salt. So the only way that you can trace the medication record is to look through the ledger and to be able to trace with the salt and the original ID, be able to trace all of the transactions in there. So that's a much better approach to anonymization, and allows you to be able to create a large ledger where the citizen would have control of their data. So the thing that's happening just now is Casper and sharding. So these are the methods that have been proposed to be able to create a new internet. So we saw with CryptoKitties, people were worried that we'd actually got to the limit of the possibilities. So you've got some really horrible cats in there. Why you would want to own those, I don't know. But the thing about CryptoKitties is they thought they were going to break the Ethereum blockchain. So it happened there, but we can see here that the transactions have actually increased. So there's a general worry about the transaction fees. That Ethereum is still not fast enough to be able to process in the way that Visa did. So this amazing genius guy, he just comes up with really wacky ideas that kind of work all the time, has come up with the new models, and it's called sharding. And with sharding, what we do is we split up the blockchain into little islands, and each island can actually operate on its own, and we create a ledger for each island. Then, if each island enter trade, then you keep a ledger just for that trade between the islands. And this way, the whole ecosystem can work just in the same way that we would do in the past when we had villages and so on. So this is the way that sharding will actually work. And it's only when we go between two shards do we have to keep a record of the transactions that happen in between. And the other thing about the new Ethereum infrastructure is it moves away from the horrible proof of work, which is very costly, towards a proof of stake. And there is some transaction fee in here, but we can make sure that we're dealing with trusted entities, and it's not just that you can actually prove that you've done the work or not. So I'd like to show you a bit of crypto. And the cyber criminals don't deal with Bitcoin as much anymore. Cyber criminals' currency of choice is Monero. And the reason they use Monero is that Monero are working through an anonymization of both the sender and the receiver and the transaction value. The problem with Bitcoin is that it gives away your identity. Like it or not, if I know that your identity is that, I can trace every single transaction you've made, and I'll probably eventually end up knowing everybody that you've made payments to. I know that you pay £10 a month to British Gas, so I'll work out that this ID of British Gas. And this is okay for law enforcement because they now have tools that can mine all of these things and looking for patterns and so on. So the problem is that this gives away both the sender and the receiver and the amount. So it's well known. So that's what it looks like. That's your private key. It produces your public address. From that key, you produce the public key as we saw, and then you take a hash, and that gives you the ID. You can't go back from there to there. That's just not possible. I do get asked that. I wonder why. I have a public key. Can I get somebody's private key? Why? Are you trying to hack their account? No. These are really interesting. Some people have got more money than sense or more time on their hands. These people have managed to create an ID. I don't know if you know how difficult that is. You've got to do a lot of computation. Detachable, I don't know if it's a word. They have managed to get an ID with normal hex characters in there. Huddle in there. It's crazy. So this is what we do. We sign with our private key, and then we prove with our public key. We put it on the blockchain, and everybody proves that we've signed over to Alice because we've put our public key on the blockchain. So you had to get a picture of Donald there. So Donald's quite worried because somebody's leaked information and he doesn't know who it was. So what we do is we create what's called a ring signature, and a ring signature allows a whole lot of people to get together and sign for something, and Donald cannot tell who it was, but he knows that some people have actually signed it. So this is the way it does it, and I'm not going to go into the crypto. You can go online and have a look at it, but basically you gather together a whole lot of public keys, you take your own private key, you flip it, you create a backdoor function, and you send it out, and you sign for the whole group. It was created by Ron Rivest a while back, but this is the way that you create anonymity on Monero. We create a ring signature, you get enough people who have the same transactions as you, and the same levels, get all their public keys and publish the ring signature. So you know at least one person has signed for that. You know, see, there's the maths behind it. Took me a while. Don't read the Wikipedia page. It's rubbish. And it's quite simple. It looks a lot more complicated. There's the Python. It does Python geek. Everything I do is Python. That's all you need to create the ring signature. And that's the verification. So the other thing that we have is what's called a stealth address. With a stealth address, what happens is that Bob knows that he wants to pay Victor, so he sends some sort of secret to Victor. Victor then creates a new private key, which will then create a public ID that Bob knows who to send to. So Victor now has a short amount of time to grab that money. So basically, Bob posts to this new stealth address that's been created. Victor knows it's going to be there. He then goes there, takes the money out, transfers it into another account because it's going to be anonymised anyway. So that's the way that Monero does it now. So that's the maths behind it if you're really interested in it. And they did it. They just went to say, yeah, on September we're just going to change over and everything will be anonymised. And they went ahead and they implemented it, and it does do it. It's the scariest thing for law enforcement ever. It's the scariest thing for anti-money laundering. And how are we going to catch criminals in the future? We've just created something. It's a beast. But no, it's right. It's right because we're preserving privacy and anonymity and consent and so on. So it happens just now with Tor. If you are a cyber criminal or a terrorist, then Tor is the choice for the connection. If you ever did it, each one gets a key. You encrypt as an onion. So when it gets to here, it encrypts to get that. You then encrypt with the green key. You unencrypt with the red key, and none of the nodes can actually see, unless you're law enforcement and you manage to get all of your jackpots up. It has happened. Academics have done that. Sat on the Tor network for a long enough time to become the whole chain, and ethically that's a bit dodgy. So you wanted to see cocaine today? I think you did, yeah? So let's have a look at some cocaine. So this is the Tor network. If you've ever seen the dark web, we have a little web, you know, that little web that we've got. There's a much bigger web, the deep web and the dark web. Okay, please shut your eyes if you're sensitive to anything here. This is what the dark web looks like. I purely went there for research, nothing else. But I've got stuff here. I love this. I'm not a webmaster. I'm not a webmaster, I'm a professional drug dealer. So that's guns in the UK. That's what the dark web looks like. Isn't that horrible? How are we going to catch our terrorists of the future if we're doing that kind of thing? So it's really worrying that we're building this monster, but and allowing it. But I think there is the possibility. I don't know if you want to click on any of these links there. One more, click on those ones. That's not what we want to do. So I think just to show, there's the iCocaine one, PharmaMaster, and so on. Let's see what I clicked on next. Do you see there? Oh yeah. Oh, credit cards. Credit card numbers. They're all on the dark web and so on. So that could be the world that we're creating because we're now allowing people to do anonymised transactions. So what I'd like to present to you is a model of the future, and it's that. So I think this is what the blockchain acts, and this is what the UK will implement in countries around the world. We will implement an anonymised, resilient, completely distributed ledger that has something on it that looks like garbled garbage that we can't make any sense of at all. If we do want to show something, we can put our identity on it, but try not to if you can. And then what we build is upper layers that start to regulate and start to build our world. So in anti-money laundering, every single bank must store a ledger which actually shows the transactions that are made and gives the linkages to the transactions on the blockchain. I don't know if you know what, I as a child remember in Falkirk there was a thing for the tourist agency. You press the button on something, that's probably not, you have no idea what I'm talking about here. You press the button and the little lights go on if you want to find the toilets in the area. Press the button and the little lights go on. Can anybody remember that?
Yeah.
Just one or two. One or two. John O'Groats, yeah, that's the kind of thing. So to me, that looks like that. Press the button, but it's either the bank or law enforcement or Bob who presses the button and who has the key and enables the shining of the light to actually show all his transactions. And for healthcare, we can create, the NHS would have to create its own ledger that was secure, that would allow Bob to be traced with inside that. So I think that's a world that starts to interest people and starts to look like a real world. So I think cryptography has the opportunity to rebuild a new world. I'm not an evangelist, please don't see me like that, but I think it has the opportunity. So what I'd like to do is, hopefully there hasn't been a power failure in Merchiston. I think there has been somewhere. I'd like to get your phones out now, and there's a t-shirt in this for you. I'm a bit worried that the network connection might have gone, so this might not work, but hopefully it will. And I think I might have lost my internet connection. That's not good. Just let me see if this is going to work. Let me turn my Wi-Fi on and back again. Is the internet connection gone completely? Oh well, never mind. Is it working? Oh, right, okay.
Use virus.
Use virus. Yeah, that's what I should use. Yes, I have. I'm a professor. I know it's pretty wacky, a professor being able to do techie things like I don't know if that. Usually they live in clouds somewhere and stuff. The practical things. We're quite hands-on. So go on. Get your mobile phone out. There's a t-shirt in there. If you get your phone, I don't know if you've got a connection. Let's see a few cats. Please, just one cat up here. Someone to do a cat. Is this not working? Oh yeah, good. Oh, cats. That's good. So get your phone out. There's a t-shirt in this for you. There we go. Yeah, we've got 11 people. 12. Oh, we've got a little love heart. That's good. I did put a thumbs down. You know, I can't take negative feedback. Okay, so we're getting there. There's a t-shirt. So who is the crypto brain of this audience? Who's been listening? That's fine. So we've got enough. Okay, everybody connected that wants to be connected. Good. So hopefully this is going to work.
Are your students allowed to take part?
Yeah, every student. There's no bias.
What about staff?
There's no bias in here at all. You just embarrass yourself if you come last, though.
Good point. I'll stay up with that.
Okay, first question. It's just not working. Connection lost. Oh, God's sake. So that's what happens when you rely on technology. Good. I tell you what, let's use my phone. Is everybody getting the connection? Okay. Okay. So don't swear. Give yourself a nice name. Don't swear. No colloquialisms and things like that. Get yourself a little pseudonym. Who's the robot guy? It's cool. Who's this one? Who's that? Who's that? Okay. Right. Okay. Wow. Oh, there's an angry robot. Okay. So you're all there. We're all ready to go. So who's going to be the crypto? I love this guy here. Who's this? That's you. Good. I'm rooting for you. Oh, cool. Come on, please. Let this work. It should work. Should work. Okay. And just let me pull this down here.
So we have a question for you.
Is it? Oh.
Questions for you.
Alright, who's the A in RSA? Leonard Adderman, Leonard Alderman, Len Ankerman, Larry Adderman, or Lizzie Adderman? Well done. Didn't even tell you that one. That said, nobody said Lizzie. That's good. If you've seen the photos, then there's no Lizzie there. That's for sure. Just 3 guys. Okay. Fake Bill is doing well. That's good. And that's good. Yeah, we're up to question 4. That's a bit worrying, but never mind. Okay, so we've got Tempe in there. So we'll just try the next one, which is not a public encryption key method. RSA, elliptic curve, Elgamal, or AES. Oh, I got you there. Elgamal is a public key encryption method, and quite a good one. So AES is the answer there. Whoever got elliptic curve wasn't listening. So there's 7 people that were sleeping through my whole presentation. That's okay. That's a pretty good hit rate for most of my classes, so that's good. I don't sleep at night. Okay, so who was the crypto genius for that one? And that's Clem is there. Oh, it's the fastest. And Blotpad, Bill, that's me. See, I'm doing it. So even Willie F, Hola Hop. And Fake Bill. Fake Bill's doing well. That's good. So for the next one, oops, I go forward 1 question too many there. Sorry about that. Go back. Okay, question 5. Okay, Bob wants to send Alice some bitcoins. Which key does he use to allow the transaction? His private key, his public key, Alice's private key, or Alice's public key? So I did outline it, I think. Oh, who said Alice's private key, for goodness sake? Those 2 people shall come up the front right now.
Sorry, Bill.
But, okay, there's a fundamental flaw that I want to think about, those 2 people, and I want to hand in your homework next week. So Bob signs with his private key, of course he does. Alice's public key, not in a million years does that happen to them. So you have most 21 of you were listening, and all the rest of you, it just went right over your heads, as I expected, but that's fine. And let's see, Hurricane Bobag. I'm so sorry for just saying that. Eve was the fastest there, but Fake Bill is right up there, winning a long way. So, which is not a token type? So I outlined 3 tokens. Which of these is not a token that we would look to in the future? Access, security, utility, or payment? Which is not one of the 3 tokens that the future will be built on? Oh, well done. That's good. Security token really needs to happen. Utility, which is app and payment, and it's access is the one in there. So let's see how we're getting on. And Ali is coming up there. Well done, is Fake Bill again. Wow, that's good. Who's Fake Bill? Oh, good. No, I'm just kidding. Excellent. There goes my identity, there's my signature and everything. You know that. Roughly how many bits does an elliptic curve public key have? I did say it, so you have no excuses, but it probably went right over your head when I said it. 128, 256, 512, and 1024. Haha. Your private key, you weren't listening. Your private key is 256 bits. That's the gradient. You have an XY point that's up there. It's both of them, so it's 512 bits. That was difficult. Nobody did 128, so at least you weren't sleeping that much. Okay, so there is one more question, I think, after that, so you can get some beer after it. So you're probably quite happy with that. Don't you just want to come back to university and study? You know, I never want to come back into university ever again in my whole life. My money's on Jut. What does that say? To Jut? Is it? Jut. Ray Jazza, and that one that was there the last time, luckily, has fallen out of the top 10. I don't have to say that one. You can cut that bit, yeah. Oh, it's on the screen, yeah. So nobody outside Scotland would know what that was anyway. So, okay, this is really difficult. For a 20-bit encryption key, how many keys are possible? Oh. If you say 20, then you are coming back to university right now. Good, don't say 20. No. 2 to the power of 20 is a million. I should have said a gazillion, and you would have said, yeah, that's what it is. Looks good. Okay, 2 to the power of 20. Remember, 2 to the power of 10 is 1K, 2 to the power of 20 is 1 meg. Sorry, I grew up in a time with 16 meg on a computer these days, so I kind of know about these things. Right, so who's the winner? Hopefully it's not that one that we saw before, and I have to announce that one. So let's see who's the crypto genius and has been actually listening to the Okay, that's good. That's good. Can you tell us what that says? Can you tell us what that says?
No, sorry?
What does it say? Sorry?
The name there is Rayquaza because it looks like the Pokemon Rayquaza.
Everybody got that, yeah? So I won't show you the leaderboard because with 2030, that one there, no one outside Scotland would ever get what that says there. But thanks very much for the presentation. Go and get some beer now and change the world. So Adrian will show you the way to get the beer.